Hello. We start herein with divisions and into almost the third video on integers. Let me just write down what are we taking up today. We are taking up division of integers. Now you know that division comes from the multiplication factor, right? That means if I am saying A, let me write it down. If I say A divided by B equals C, that means what? B multiplied to C, this would derive B multiplied to C, which gives us A. Okay. Similarly, if I am multiplying a negative with a positive, if you recall your multiplication, you will get an answer which is negative, right? Based on that, whatever you have learned in the multiplication, you will see that if you are dividing, that means if your dividend, let me write down, if your dividend and divisor are both positive, dividend and the divisor are both positive, then your quotient will also be positive. Quotient is positive. I'll make a table just to help you remember this one. Either of them are of opposite symbol, right? If a dividend is positive and the divisor is negative, or the dividend is negative and the divisor is positive, in that case your quotient will be if either of the dividend or the divisor is negative, then your quotient will also be negative. So what do we infer? Let's draw a table to help us remember this. I'll make 4 columns. As I'm not making 4 columns, I'm just writing division there because our whole function is about division. This here stands for what might be your first number, the symbol only I'm talking about, and this about your second number. Again, we are talking about the symbol of the second number. If first number is positive and the second number is also positive, that means I'm talking about the dividend or division, your resultant quotient will also be positive. If first number is positive, the second number is negative, the quotient will also be negative. The other way around, if the first is negative, second becomes positive, your quotient is also negative. If you have both negatives, then your answer be a plus. That means the divisor, here I had written the divisor and the dividend either both positive, or if they are both negative, the quotient will be positive. Let's see a few examples. Minus 20 divided by 4. If you see, this falls into your third category. This is your first one, this is maybe third, this is fourth, and third, and this fourth. This falls into the third category, so your answer will be in negative. 20 divided by 4 will give you 5. So your answer remains minus 5. Next can be 18 divided by minus 9. So what do you get? Sorry. Again, this falls into your second category. Your first number is positive and the second being negative. Your answer will be negative, and 18 divided by 9 is 2. Let's now see the first and the fourth case, wherein you have both of them negative. When you have both negative, your quotient is positive, so you simply divided 56 by 2, that gives you 28. Now we take 2 positive, that's a simple division, like maybe 18 divided by 3. So both positive, your answer will also be positive, that's 6. I hope you follow this. It's kind of not that difficult to recall. Remember, we would now move on to the properties of integers. I write down here that we are taking up now properties of integers. Let us take first example. I'm doing the first one, the closure property, and we'll see how it works under each of the functions we have learned, that is your addition, subtraction, multiplication and division. So it is closure property of integer. What does it say? Let's see, if I add two integers, whatever it might be, just 2 positive, if I add, I'm getting 9. That's another integer. If I add maybe 1 positive with a 1 negative, I'm getting answer 1. That's again a positive. That's again an integer. Or if I add -4 with -5, I'll get a -9, which is also a positive, an integer. Let's see under subtraction what happens. If I subtract -4 and -1, that means I'm subtracting 1 from -4, my answer becomes -5. Now if I subtract -3 from -5, that will give me an answer of -2. Or if I simply subtract -2, a positive and a negative, I'm getting a 3, which is again an integer. Move on to take up multiplication. I multiply 4 with 5, I get a 20. If I multiply 1 negative and 1 positive, I'm again getting -20, which is again an integer. I might multiply 2 negative numbers as well, which is giving me a positive answer. If you see, in addition, you are getting all the sums being integers. Here after subtracting also, you see your results are all integers. Even in multiplication, all of them, be it positive or negative, they are all integers. Now move on to taking up division. If I divide two positive integers, I am getting 3 as the answer, which is again an integer. If I am dividing two negative numbers, I am also getting an integer. If I divide one negative with a positive, I am not getting here any integer, right? It will just be going some 3 point something, so it will not be integer. Or even the other way around, if I am dividing 3 by -7, that will also not give an answer, which is integer. So what we derive from this example is that addition of integer is closure under addition. I just missed it. The closure property of addition is applicable to addition, subtraction, multiplication, but integers are not closed under division. That's our first property. So I'll write here above, our first property is integers are closed under addition, subtraction, multiplication, but not under division. So that's our first property, that's closure property of integers. Let's move on to take up the next one, which is commutative property of integers. Our second property is commutative property of integers. Now what does this say? Let's see. I'll first be taking up under addition. I'm writing it. If I'm adding suppose 5 with 7, I'll get an answer 12. Now this 12 can also be derived when I change the sequence and write 7 plus 5. Let's take up one negative and one positive and see. If I'm adding 8 with suppose a minus 7, what do I get? I'm getting 8 minus 7, that is 1. Now if I change the sequence, I'll write minus 7 first and plus 8. That will also give us 1. I can take two negatives as well. Minus 8 plus minus 7 will give us a minus 15. Even if I write, minus 13, minus 15. I wrote it. I missed one there. Now if I am writing minus 7 and then minus 8, that also will not change my answer of minus 15. Let's see the same thing with subtraction. I might subtract 4 minus 6, my answer is a minus 2. Even if I write minus first and then 4, my answer will remain same. Oh no, it's not remaining same. No, if it is a subtraction, it will not give us the same answer. If I am writing, like it's my 6 is subtracted from 4, I can subtract 4 from 6, so that will not give me a minus 2 answer. Instead, that will give me a 2 answer, right? Or if I am just subtracting a negative number, I'm subtracting now minus 6. I'm subtracting 6 from minus 4. That will give me minus 10. Now let me subtract minus 4 from 6. Minus 4 from 6. Will this give me a 10? But it will give me a 10 but not minus 10. So if we change the sequence under subtraction, we see that we are not getting the same answer. Now move on to multiplication. Let's multiply any two positive number. I'm getting 4 into 3 is 12, and if I even change the sequence, I'll multiply 3 into 4, that will also give me a 12. Let's take up a negative number with a positive number. So this will give me a minus 12. If I even change the sequence of multiplying 3 with minus 4, that answer will not change and will remain as minus 12. Let's multiply two negative numbers, like minus 4 multiplied to minus 3. I'm getting a plus 12. Now if I change the sequence, like minus 3 multiplied to minus 4, that will also let me have the same answer of 12. So under multiplication, we can also change the sequence. We now move on to the division part. Let's see. If I divide, suppose 12 by 6, I'll get 2. But I'll not get the same answer if I divide 6 divided by 12. This answer will be like 1 by 2. I'll write it a little neatly. This will be 12. Now if I take a negative number with a positive number, this minus 12 divided by 6 will give me a minus 2. But if I am dividing 6 by minus 12, that will give me 1 by minus 2. That's also not equal. I might take two negative numbers, like minus 12 divided by minus 6 will be only 2. but the same answer will not derive if I am dividing minus 6 by minus 12. That will give me a 1 by 2 then, right? So what we derive is, under the commutative property is applicable to addition and multiplication, but not under subtraction and division. I'll write it here, what we derive from above. Addition and multiplication of integers are commutative. Subtraction and division are not commutative. These are all, I just forgot to write subtraction and division of integers. We are talking about the properties of integers, so this will be applicable. So this is our second property. First we had learned in the previous page about the closure property. Here we have learned about the commutative property of integers, right? And the next one will be identity property, and there will be associative property, which we'll be taking up in the next video. Thank you.